With the phenomenal uptake of electric vehicles and limited electrical grid capacity, there is a growing need for energy management systems, or EMS. EMS are able to dynamically distribute available power in order to optimize the economics of a grid connection while meeting users' needs. Increasingly, GreenWay finds itself providing its clients not only with electric vehicle charging stations, but also with ways to manage their energy. However, there are only a few EMS systems suitable for EV charging on the market today. GreenWay's in-house R&D team is running its own project on the topic and also participating in the iSTORMY project, wherein there is a specific use case of an EV charging hub with the support of a stationary hybrid energy storage system and customized EMS. GreenWay is happy not only to share its practical experience with similar solutions, but also to test the novel iSTORMY solution in a real-life environment, where the goal is also to reduce the total cost of ownership of energy storage systems by 15%. We're joined today by Thomas Geury from the Vrije Universiteit Brussels, or VUB, who is the coordinator of the iSTORMY project. Hello, Thomas.
Oh, hi.
Hi, it's great to have you here. Thank you for joining us to help inform people about the iSTORMY project. You heard the description I gave of it. Is there anything you would like to add to the description of the project for people who are not yet familiar with it?
Yeah, maybe I can add a few words on iSTORMY. So it's a European funded project. Indeed, that started in December 2020, a bit more than 2 years ago, and is going to last for 42 months in total. So we have 12 partners involved in the project. We are coordinating from the VUB side in Belgium, and we have a total funding of around 3.5 million euros. Of course, you can see all information online. And our idea, as you mentioned, is to develop a hybrid energy storage system that's going to support the grid if needed, provide a bit of buffer also to EV charging stations, so the use case from GreenWay. And then also we really aim at optimizing the system itself. So the configuration of the system with hybridization from the batteries and the operation with also the energy management within the system that's really aiming at increasing the lifetime and the reliability of the system itself. Okay. Yeah, that's a few words on the project.
No, super, that is helpful. And I mean, can you just elaborate a little on the need for energy storage in general in these cases? I mentioned, kind of grid connection and capacity issues, but maybe you have some more to share on that.
Yeah, indeed. So, well, one of them, of course, is with the rise of electric vehicles. They're going to be charged from the electricity grid. In most cases, the grid has not been sized accordingly, has not been designed to welcome such charging stations. With storage system, we can actually act as a buffer to perform some load leveling, peak reductions. If we support the charging from the electric vehicles from the batteries when needed, and when there's no charging, we can just take energy from the grid. So it's this kind of buffer that we can optimize. That's one with the charging of electric vehicles. But then you have many other issues that need to be compensated from the grid. For example, you have also renewable energies that are fluctuating, that are not producing at all times. So it's good also to have this backup from the storage systems. And then you have the frequency that also needs to be regulated on the grid. So you can have this frequency regulation, and you have several use cases that need support from this kind of storage systems, especially with the new scheme in the electricity grid with renewable energies, electric vehicle charging. So it's really, it's a must at this time to develop this kind of storage solutions.
Okay, so the idea is that there would be energy storage devices, so large batteries basically, on site where there is a lot of need for electricity, to support let's say the appliances that are using, whether it's electric vehicle charging stations or heat pumps or anything else. In addition to getting their power from the grid, they can also get it from these energy storage systems or batteries. Is that correct?
Yeah, indeed. But then you have different applications. Some can be locally in the microgrids if you have EV charging, but then it can be also really from the grid perspective and not next to the house. Or we are more looking at a large capacity storage that can support the grid itself. Yeah.
Okay. So physically, what are we talking about here? What is it actually concretely that would be that you're ultimately working to produce and that then would be, located at these locations?
Yeah, so it's an energy storage system. That's the system level. Here we are looking at hybrid energy storage system. So it means you have two different types of batteries to really be able to optimize the operation of the system, produce high power when needed, but still being able to store high energy content in the batteries. So we have two batteries with different characteristics. These are actual battery packs, battery cells, lithium ion most often, but not only. And these are connected to the grid with power electronics devices. So we have DC-DC converters, we have DC-AC inverters, then to integrate this to the AC grids. And these are physical power electronics converters. And then we have also hardware EMS platform that controls the system to provide the required power to the grid and, as I said, to optimize really the operation within the system also. When do we need to provide power from the one of the batteries? When do we need to provide it from the other one to increase the lifetime and reliability of the batteries?
So, in the introduction, I said that there's not a lot of energy management systems that are suitable for these types of applications. Can you elaborate on that, please?
Yeah, so actually, as of now, there are, not many storage systems overall. With introducing storage systems, the idea is to really develop the EMS that comes along to support certain types of use cases. So of course, we need to have different types of EMSs for different types of use cases, whether you want to do frequency regulation, compensate the peak from EV charging, or really suited to the specific use cases. One of the highlights also in iSTORMY is to have a self-healing EMS within the system. So in addition to providing the service to the grid, this self-healing EMS is going to monitor the status of the batteries, of the power electronics, to really detect when a fault is likely to occur in one of the devices, which preventive actions we should take, and really have this kind of precise monitoring over the whole lifetime of the batteries and power electronics.
Well, that's really interesting. And when you say over the lifetime of the batteries, now I understand the project is looking also using second life batteries, so batteries that have, let's say, come to the end of their usable life, maybe in automotive, but still have a lot of available capacity left. Can you speak to the use of second life batteries in this project, please? And I guess it's particularly interesting in light of the coming European batteries regulation, where they're really putting a lot of emphasis on recycling and reclaiming materials from older batteries, but also using batteries for additional purposes beyond their first life.
Yeah, indeed. So, in a car, the battery capacity is, of course, really critical, because when it reaches below 80% of capacity left, usually it's replaced, but it's still totally usable, especially for this kind of stationary storage applications where the weight is less critical. So in a car, of course, you want to optimize the weight with regard to the autonomy. Here, it's less of a problem. So it's definitely an interesting solution to take these second life batteries, use them in stationary applications. It's something that we have considered in the system design optimization at the beginning of the project, So we had different options for types of cells, types of batteries to be considered. However, it was not selected here due to still the high price and low availability of these types of batteries. Still, we expect it's indeed, well, due to regulations, you mentioned due to availability also, when the first generation of EVs will need replacement of the batteries, and we have a whole lot of batteries available, the prices will also decrease. Then it will definitely become one very, very interesting solutions. So I assume in the maybe next wave of stationary storage systems, it should be something that will be considered, even though, yeah, we did not actually implement it, because at this time, it's more of a really research item that's not a viable solution yet in terms of economics.
So interesting. Do you see it as something promising for the future, or it's too early to tell?
Yeah, well, it's too early to tell for sure, because you never can predict the price of storage systems over a few years. But yeah, in my opinion, it will be for sure. It's really a matter of availability. I think now it's still very early stages, meaning that these batteries that come at Second Life have not been prepared to be used in Second Life applications, meaning you don't have the full history of the usage of the battery. You don't have all the data available, so you cannot really optimize its usage in Second Life. It's still not that easy to refurbish, to reconfigure the batteries as needed to be used in Second Life. But in the future, well, all of this will be considered. I already see new horizon calls where this should be tackled. So I believe by 2030 we'll have probably a good market on Second Life EV batteries. Yeah.
Interesting. And so you're saying that already calls are going out, and private research is probably being done as well, for battery packs and ourselves, where the Second Life is already taking into consideration and the requirements for knowing the history and the, let's say, chemistry and the durability of each specific battery is already taken into account, and passports are issued and things like that.
Yeah, indeed. Yeah, so battery passport you've mentioned, that's something that should be considered. And then, yeah, they're called specifically on the design of first life batteries to be used in Second Life applications, to be easily refurbished, reconfigurable, to be used in this kind of stationary applications.
And when we talk about these first life batteries, are they primarily for automotive purposes in their first life, or is there something else?
Primarily, yes, but then, well, as of now, in stationary applications, you have first life batteries as well. Of course, well, you have many devices relying on batteries, but here we are talking
about device we're recording on, in fact.
Yeah, indeed. Well, computers, smartphones, everything, but here we are talking at higher capacity batteries, so typically the ones from actual vehicles. But then at this stage, stationary household batteries are becoming more and more popular, even though it's still at a low increase rate. But these are all first life batteries, which could potentially be valorized somehow in their second life.
I see. So when you use the word hybrid in the context of the iSTORMY project, you mean then there's different, let's say, capacity types. There's different types of batteries in the same pack with different capacities? Or is that, can you elaborate on that?
Well, in the same system, in the same enclosure, because we have one storage system overall. But then we looked at not only different capacity, but really different types of cells. So cells that can have higher power output, or that have rather higher capacity. So we're talking about NMC, LTO, LFP cells. So second life batteries, you can consider them rather at high power, because you've already sort of used them. But then these different characteristics will really provide different types of operation for the system. So, For example, LTO cells can be used maybe up to 4C. That means they can provide 4 times more power than another cell like LFP, which is rather used at 1C, providing they have the same capacity. And this is really interesting because it means that you can, with one single system, you can really provide different types of services, some that require higher power and other ones that require capacity storage over a longer duration. And this means our system can be interoperable for different use cases. So you don't need to build a whole new system. For example, if your use case has different characteristics, you can reuse this same system using the different types of cells that are in there.
When you say, oh, sorry. No.
Oh yeah, if I can add, so this really provides also room for optimization within the system in terms of how we are going to operate it. So if you have a certain output power that you need to provide to perform your use case, then you can play with, is it coming from the high power battery? Is it coming from the high energy battery? How is that going to affect the lifetime of the batteries? So it's really this kind of optimization that you can have internally within the storage system.
And is the energy management system what is making those decisions for different applications at any given time?
Yeah, it is. So there are different layers in the energy management system. One of them is really to provide the service, the use case, for example, EV charging load leveling. Another layer is how this is going to be provided, taking into consideration the information from the BMS battery management system that collects the data from the batteries, that really makes sure there is proper balancing within the cells, etc., and the low-level controllers from the power electronics, which also do the interface between the actual power electronics devices and the EMS hardware by while doing the low-level control, of course. So making sure the actual power set points are followed and retrieving some information on the current voltage of the converters, the temperature, also that gives really good indications on the consumed lifetime of the devices. And this kind of analysis coming from both BMS, low-level controllers, central EMS will provide really good information to increase the lifetime and reliability of the overall system.
Mm-hmm. And is the central EMS effectively a computer, a software, like an algorithm?
Yeah, it is. Well, it's based here on hardware devices where we implement our algorithm in Python in this case. Mm-hmm. In the future, we are also looking at having that operating in the cloud, because that means you can run more, you have more computational power potentially, and you can really even run the full digital twin of the system there. So that means you have models closely replicating the behavior of the full system. That's running in parallel in the cloud, and when you see that there may be a fault occurring, or that one of the switches, for example, one of the battery modules is really aging faster, or is likely to heat too much, or is likely to break for some reason, you can anticipate that and take preventive actions already in the system without waiting for the actual failure. That means the system is not going to be available for some time. That's going to cost money also. Yeah, so it's really this kind of optimization we are looking at, even though we do not have the full cloud or architecture yet in iSTORMY.
Not yet. All right, well, it's a research project, right? So
yeah, indeed.
You mentioned longer duration storage, and just how long are you talking about there?
Right, it's up to, so it's not very long duration, up to maybe 1 day, depending on the use cases. But yeah, if you cannot, because it depends. If you need to provide energy for full day, then you need to size the batteries accordingly. So they have to be sufficient in capacity to provide that to the specific use case. But yeah, we are not looking at more than 1 day in this case.
Okay. No, it's very interesting. I mean, the whole concept of longer duration storage and what does that even mean? It's just a very interesting topic these days.
Yeah. But it's really specific to the design of the system, the use cases. Sure. Here, when you talk about frequency regulation, it's also much shorter time. So it really depends on the use cases, indeed.
Yeah, absolutely. The project is covering and doing so many things, it sounds like. So there must have been challenges, obstacles to overcome along the way. Can you share what some of those have been?
Yeah, so it's the challenges. There are many indeed in this kind of research project. One of them is the availability of components. So since the COVID crisis, we've seen that many components are in shortage. That can be on the batteries or the power electronics, but that definitely causes delay in the manufacturing of the components. And yeah, we consider this kind of risk in the project implementation, but then you actually still hope they're not occurring. In the sharing maybe of the information between the manufacturers, the research partners, it's always something that's challenging. Also because ideally for the modeling you need all the data to be available, but then from the industry it's not easy to share everything. So it's also a kind of mitigations that we need to find, and then we are actually at maybe one of the most challenging stages of the project, where we are going for the integration of the system. So we have the different components, batteries, power electronics, EMS, nearly finalized, and now we need to put them together. But that means we need good interfacing between the components. We need good synchronization. We need to double check the communication, electrical connections as well. And that's going to be a challenge as well. But I believe we did good preparatory work to overcome that.
Well, the coalition is large and a really diverse group of institutions, and GreenWay is one of them. So I was wondering if you could share a little bit about what GreenWay is uniquely bringing to the project.
It's GreenWay's contribution is mainly on the EV charging use case. So it's really good to have one partner that's dedicated to operating this kind of EV charging stations that can provide all the related information. And actually we had a good cooperation as well on the second life battery information from GreenWay to really get all the necessary data to be included in the design optimization, in terms of costs, also to see whether this could be feasible or not. And actually this work is also still ongoing on the maybe more advanced EMS, because in addition to the use cases that we're going to test physically, we also have a few more feasibility studies on the EMS side, and there GreenWay is involved as well, with developing the EMS a little bit further in more advanced use cases, more research ones that will in the end not be implemented.
Got it. Well, I mean, it sounds really exciting, very, very timely. I know GreenWay's research and development department is very excited to be involved, and we're very happy to be able to have this discussion with you and share a lot more about the iSTORMY project with interested parties. So Thomas, thank you very, very much for your time, for your coordination efforts, and I don't know if you have any final words you want to share before I know you need to run to your next meeting.
No, well, maybe for the last few months of the project. So as I said, we're looking into the integration, and then we'll be happy to share the final results when we have them at the end of the project. So thanks anyway for your interview, for the involvement of GreenWay, and thank you.
Thank you very much. Good luck.
Thank you.